All right, hello everyone. Today we're going to finally get to solve some equations, which is basically a lot of the purpose of mathematics. I talked about that a little bit in our last time together when I encouraged you to go to a grocery store and to examine cans and see which ones are more efficient in their design. Efficiency is something that mathematics is really good at, showing what kind of a figure would take the least amount of material to hold a certain amount of stuff. Like for instance, just before we even get into these equations, if you think about it, if you want to send a box through the mail, whether it's through the United States Postal Service or whether it's UPS or FedEx, if you want to send a box to someone, if you want to get the absolute most stuff in a box in comparison to the amount of cardboard that's used to make the box, you're far better off sending a box that is a cube, where the length, the width, and the height are all the same. Okay? The fascinating thing is a cube the absolute best shape to use when you're building something? And the answer is no, it's not. If you want to make it round on the sides, like a cylinder, like a tin can, it is actually better than a cube. You can actually get more stuff in a cylindrical shape. All right, in other words, more stuff in relationship to the amount of material it takes to make than a cube. So a cylinder is technically better than a cube. Now, thinking about all that, if you just brainstorm a second and think, well, is there any shape that's even better than a cylinder? Okay, and there is. There is one shape that's even better than a cylinder, and that is a perfect sphere. A sphere is the absolute best shape as far as building something that'll hold stuff. Okay, the only problem with a sphere, like for instance, just on the other side of the river in Northumberland from Susquehanna University, there's a big fuel depot out there. And if you drive past that horrendously big place where gasoline and oil and whatnot, diesel fuel are stored, you'll see that the vast majority of those huge monstrous tanks are cylindrical. Okay, so they're actually doing not too bad as far as building something that will hold stuff in relationship to the amount of material it takes to build the surface. The absolute best shape they could build to hold fuel would be a sphere, perfectly round like a ball. But I think you can readily agree there'd be some problems there, because how do you support it that it doesn't roll away? Are you with me? Okay, so the actual physical attributes of a sphere make it a little bit tricky, but still, the truth of the matter is, a sphere is better even than a cylinder, that it takes less material to hold the same amount of stuff. Very fascinating concept. And it even gets better. I should have even started talking about this. It even gets better when you go back to cubes that you're sending through the mail. Okay? What if you take the lid off the box? Is a cube still the best shape if it only has 5 sides instead of 6? Okay, is a cube? No, it's not. The minute you take the lid off the box, you can build a box in a different way that it'll still hold the most stuff, but it will not be shaped like a cube. So it's very fascinating topic. And if you want to know more about that, take pre-calculus and calculus. The best subjects there are. All right, so anyway, so we're talking about solving equations today. These are going to be linear equations in which we have one variable, and the variable never has an exponent more than 1. Okay, there's never an x squared in it. All right, so let's talk about solving linear equations. And some of these initial ones here are really easy. You've done these before back in high school. When you have something like number 1, x plus 8 equals 13, the analogy I always use is a seesaw at the park. Okay, you all were at a park, I'm certain, at one point or another in your life, and you were getting your seesaw perfectly balanced with your best friend on the other side. Okay, then one of you decided to jump off. Well, The other person who did not jump off is in for a rude awakening, okay? He's going to come crashing down to earth quickly. If it would be possible, once you get your seesaw balanced, if you could both jump off at the same time, the seesaw would stay balanced, okay? And that's what we're doing in equations. It's like a seesaw at the park where the fulcrum, where the pivot point of the seesaw is the equal sign. Whatever you do to one side to preserve the balance, you must do to the other side. I want to get rid of the 8. I want to find simply what x is. Since it's a plus 8, I want to subtract 8 from both sides. And I get that x is equal to 5. Okay? You've all done these before. How about this one? 8 minus x equals 12. Now, in this one, there's 2 steps you need to go through. Number 1, you have to get rid of the 8. Number 2, you have to get rid of the negative sign. You want to find out strictly what x is. Okay? So, now here's a tricky problem. Some people say, well, the 8's connected to the x by subtraction, so I'll do the opposite. I'll add 8. No, that's not going to cut it. This is a positive 8, period. If it was x minus 8, it'd be totally different. But this is a positive 8, and to get rid of a positive 8, you must use a negative 8. I get negative x is 4, okay? Now, to get rid of the negative sign, you can multiply both sides by a negative or divide by a negative, and you get x is negative 4, okay? Now, there is an interesting way to do this same problem in a different manner, okay? We started with 8 minus x equals 12, all right? Why not get the x positive? Why not add x to both sides and get 8 equals 12 plus x, then subtract 12, and you still get negative 4. Okay, that's the way I like to do the problems. I like to get rid of negative signs as quickly as possible. So there's a couple different ways you can do this. How about number 3? This one is unique from what we've done so far. Do you see you have x's on both sides of the equation? All right, now when you have x's on both sides of the equation, I would encourage you to get rid of one of the x's right away, okay? So in other words, you've got 4x here and 4x here. It's going to be an interesting problem, folks. Let's get rid of this 4x. Let's subtract 4x from both sides. And look what happens. I don't bother writing the 0 here because I already have a number over here to hold this value on this side. But 4x minus 4x is 0. And you end up with no variables at all, and negative 4 is equal to 0. Can everybody see that okay? Am I writing plain enough today? All right. You end up with negative 4 is 0. Well, this problem really is not that difficult. You just say to yourself, negative 4 equals 0? How often is that true? Negative 4 equals 0? That's never true. There is no answer. I put a circle with a slash through it, meaning that there is no answer to the problem. I don't care what you pick for x. Nothing will ever work. Okay? Let's try the next one. I think the same thing is going to happen in the next one. You have an x on both sides. If you subtract x from both sides, you get negative 4 equals negative 9, and precisely the same thing happens. That can never happen, all right? So there is no answer to the problem. Put your circle with a slash through it. All right, let's move on. Make it a little bit more interesting. Here we have x's on both sides again. 5x minus 14 equals 8x plus 4. I'd always work with the x's first. If you have x's on both sides, try to get them all on one side. Do you want to get rid of the 5x? Do you want to get rid of the 8x? I think one way is a little better than the other, okay? One way is a little better. I would suggest getting rid of the 5x, because if you subtract 5x from both sides, you can see that you're not going to get a negative here. And most errors that math students make in problems like these are negative errors. All right, so you're avoiding a negative sign. I have negative 14 then equals 3x plus 4. Follow what I'm doing? No negative sign here. Now you can subtract 4 from both sides, and you get negative 18 is 3x. Divide by 3, x is negative 6. Okay? Everybody still see that okay? My marker's starting to get a little weak. So I'm going to have to either write bigger or get a new marker, I guess. This one is dying on me. Oh, there's my friend back again. Oh, boy. Okay, let's try the next one. Negative sign, 7 minus 4x equals 9, okay? You got a choice here. I don't care which way you do it. I would probably take the negative into both parts and get a negative 7 and a positive 4x is 9, okay? And then, suddenly, excuse me a second, see if I can get this better so that, yeah, I think you can see that. Okay, so now all you have to do is get rid of the negative 7. Let's add 7 to both sides. And that step is so easy. I just get 16 divided by 4. I get x equals 4, right? And you can always take the 4 and put it back up in to check it. 16. 7 minus 16 is negative 9. The opposite of negative 9 is positive 9. And it checks. How about this one? 3x minus 7 equals 3 times x plus 8. Maybe some of you, if you look ahead, can kind of guess what's going to happen here. All right, take the 3 into both parts. I get 3x minus 7 equals 3x plus 24. X is on both sides. Let's deal with that right away. Subtract 3x from both sides. And I get negative 7 is 24. That cannot happen. Okay? Cannot happen. So there's no answer to that problem. All right, number 8, 2 times x minus 7 equals 2x minus 14. Take the 2 into both parts. I get 2x minus 14 equals 2x minus 14. If you subtract 2x from both sides, you get negative 14 is negative 14. And how often is negative 14 equal to negative 14? All the time. So if it's true all the time, x can be any real number. Just right, it can be anything. I don't care what you pick, all right? Pick any number whatsoever. How about 3? 3 minus 7 is negative 4. 2 times negative 4 is negative 8. 2 times 3 is 6. Minus 14, negative 8. Works. True on both sides. All right. Oh, equations, solving equations. A lot of fun. Okay, some more interesting ones here. This one, we have to do some collecting of terms first. 8x plus 5x is 13x. 4 plus 1 is 5. Equals 12x plus 2, yes. Which x would be smarter to get rid of? 12x, yeah. Subtract 12x from both sides. You get 1x over here is 2. Subtract 5. And I get x is negative 3. Okay? For number 9. Number 10, we've got to collect some terms there. Let's do that. On the left, a negative 3x and a 4x is 1x minus 11 equals, over here, 8x minus 6x is 2x minus 7. All right? And now we should be ready to solve this one. You want to get rid of the 1x or get rid of the 2x? I get rid of the 1x. Try to keep your x's positive. Subtract an x. So negative 11 is x minus 7. Add 7 to both sides. I get, subtract and give it the sign of the biggest. Negative 4. There is my friend back again. I tell you, that guy is persistent. Okay. So the answer to number 10, x is negative 4. And if you put it back in, it should check and make a true statement. How about number 11 is negative 8x plus 4 is negative 6x minus 2. Got x's on both sides. Now this one, be careful here. This one, they're both negative. You got to pick one to get rid of, either the negative 8x or the negative 6x, and try to avoid negative signs. So to avoid negative signs, I'd get rid of the 8x. I would add 8x to both sides. And that's going to give you 4, 8x and a negative 6x. You subtract and give it the sign the biggest, 2x minus 2. My marker is fading. Add 2 to both sides. I get 6 is 2x. Then divide by 2. By the way, when I divide, I often do this fraction. And some of you might be sitting there and saying, I know that 2 into 6 is 3. I know that it's the answer. Do I have to do that? The answer is x equals 3. The reason why I do that, okay, suppose this 2x, just suppose it was a 5. You would divide both sides by 5, and you have your answer on this side instantly, 6/5. You can let that as your answer, 6/5, or 5 into 6 goes 1.2. I don't care. But because you divide and show me your fraction, that is an answer. Okay, so it's a good reason to write the division symbol, the dividing bar, and you get the answer of 6/5 if it was a 5. Oh, for heaven's sakes. Persistent little bugger. Okay, number 12. I have x minus 5 minus x plus 5 equals 10. I would take the negative in here. There is nothing to take into this one. So you can simply drop the parentheses, x minus 5. Now, take it in as a negative x and a negative 5. The x's go away. Negative 5 and negative 5 is negative 10 is equal to positive 10. How often is that true? Never. Never. Okay? Never, ever, ever true. Okay, so that takes us down through number 12. And we've got a couple more, 13 and 14. Okay. So now here on this problem, when you have a fraction equal to a fraction, okay? A fraction equal to a fraction, one of the best, absolute easiest ways to work this out is to simply cross multiply. Cross multiply across the corners. You can only do that when you have a fraction equal to a fraction. Okay, so make sure that permeates the gray matter up here. I'm going to cross multiply. 6 times this is 18x plus 12 is equal to this times this is 8x minus 16. Everybody with me? Okay? Now, I've got x's on both sides. Okay? Do you want to get rid of the 18 or the 8? Easy. Keep it positive. Subtract 8x is 10x plus 12 is negative 16. Get rid of the 12 by subtracting. I get 10x is negative 28. And you see what I mean about dividing by 10? Okay? You get negative 28 tenths, which you can divide and get negative 2.8. Or you can reduce it and get negative 14/5. Or negative 2 4/5 is a mixed number. Okay? However you want to do that is fine. How about this problem? Let's cross multiply here. I don't care which way you get started. So I'll take 3 times this, 3x plus 15 equals 8x minus 4. Yeah? Which x to get rid of? The 3x to keep it positive. 15 equals 5x minus 4. Add 4 to both sides. I get 19 is 5x, divide by 5. And when you divide by 5, see, there's your answer. 19/5, or 5 into 19 goes 3, and 2 left over. 3 and 4/5, okay? 3 with 4 left over. Or you could divide it out and get 3.8 on a calculator, all right? Any way you want to write your answer there, but you should try to reduce any fractions if you're going to let them as a fraction, okay? All right, so homework is as before, the other pages that are part of your homework, and have fun solving equations.